Right, I've constructed a baseline here and one corner which I've measured and constructed a 40-degree angle. So I've labelled that corner or vertex A. Now I'd like to construct a larger than 90-degree angle at the top or the apex of this triangle. So that would actually make that an obtuse angle. So I can construct obtuse angles also using my protractor. So I'll just swing the paper around so that line is on the base, simply because it's easier for me. And I can construct it at any length here. So I might just work with the end of the line. And let's see, I want it to fit on the page, so I'll come back a little bit here and I can see if I made it 110, that would fit on the page. And here, 110, it would certainly be quite a distance. So I might just start here. So I'm going to label that B. Put that point B on the point where the 90 and 0 lines intersect in the middle of the circle, and I'm counting up from 0. So I've gone 10, 20, 30, right up to 90. Now I'm found 110, so 90, 100, 110, and that would make that a reflex angle. So I put a dot just through where 110 meets 70, and that's simply 2 rows of numbers. So now taking that off, I draw a line through B and the dot I've put on the edge of the protractor, and that will make that angle 110 degrees. So now to find the magnitude of this other angle, I can use the fact that I know the sum of the angles of a triangle 180, so I would have to go 180 minus 40 minus 110 degrees. So together that would be 180 degrees minus 150, which would make that 30 degrees over here. So I have a 30-degree angle. So what I did there was I added 40 and 110 and I got 150. So 180 minus 150 is 30. So now I've got all those measurements. Now I have constructed here an exterior angle. So I've extended that baseline beyond. I've extended this baseline here beyond. So I have an exterior angle in here, and I have an exterior angle in here. And if I extend, well, let's see, that might be enough for the moment. So let's measure this exterior angle using our protractor. Put the point C on the intersection point, and counting up here, we find that we actually get 150 degrees. So 10, 20, 30, 40, up to 90, 140, 150. So that's 150 degrees in here. So that's the exterior angle of the triangle. Now we've got another exterior angle over here. So if I measure that one, now this time I'm going to have to use the measurements on the outside because they start with 0, and I could measure up here and I could go 0, so from 0, 10, 20, 30, 40, 50, 60, 70, so that is 70. Of course, I could have calculated those because they're both on straight angles. 110 plus 70 will give me 180, and down here 30 and 150 will give me a straight angle, which is also 180. But there is another relationship. Can you spot it? 150 here is actually the sum of the two opposite angles which are inside the triangle. So 110 and 40 will give me 150. And also here, the two opposite angles which are not involved in this calculation are 30 and 40. And if I add those together, they get 70. So also the exterior angle is 70. So the exterior angle rule says, and it's quite a mouthful, it says that the sum of the two opposite interior angles equals the exterior angle of the triangle. And that's the exterior angle rule.